Hello. So for this problem, we're going to be calculating the probability of finding the electron in the first excited state of the hydrogen atom more than 4 alpha naught away from the proton. So for this equation, we're going to have the radial probability density for the first excited state where n equals 2. It's given by this equation. And then we want to find the probability where this equation has an r greater than 4 alpha naught. So we'll be taking the integral from 4 alpha naught to infinity of p of r dr. So starting the integral, we're going to have 4 alpha naught to infinity of multiplying the r squared through and the square, r squared over 32 a naught cubed, 2 minus r over alpha naught squared, e to the negative r alpha naught dr. We can pull out the 1 over 32 a naught cubed because that is not part of our integration of r. So then we're left with that equation. We can simplify this. We want to kind of write out our 2 minus r over alpha naught squared here. And that becomes 4 minus 4r over alpha naught plus r squared over alpha naught squared. So then we can put that back into our integral. And this is a very difficult integral. I don't know how to do it, so I plugged it into an integral calculator, and it said that it was equal to 45 e to the negative 4 over 4, which is approximately 0.206 or 20.6%. And that percentage value is the likelihood of finding the electron in the first excited state of the hydrogen atom at a distance further than 4 alpha naught away from the proton, where 4 alpha naught is the most probable location the electron will be. This seems reasonable using my solution from exemplar 3, which was the 4 alpha naught. Because with the probable location being there, there must be other locations outside of that value that cause the average position to be lowered to its average value of 1.5 alpha naught, which I also found in exemplar 3. The higher values compared to 4 alpha naught will be a lower probability in this case because the average is lower than 4 alpha naught. Since the average is lower, there's a higher probability that the electron will be inside of 4 alpha naught. You can kind of see that, if it was a graph with our percentage of finding the electron, we have 4 alpha naught as our most likely, 1.5 as our average. Say it would be here, it'd be a spike, and then it'd be lower, where this is like our 20%. This is our highest value, and then we have whatever's going to lower it to 1.5. So, yep, thank you.